Hello, my Algebra 2 crew. We are going to do Day 2, Unit 3 notes, function vocabulary, and even odd functions. So I told you yesterday a lot of this is review from Algebra 1. So let's go through some vocabulary really quick. I left a little spot in the vocabulary notes here so that we can do a couple little mini graphs for you to see some of these. Okay, we're going to talk about function vocabulary, and the first ones have to do with what we call increasing, decreasing, and constant. And when you look at a graph, you always look at it from left to right. And I just put there three scenarios where I've got a increasing, decreasing, and constant. So let's see if you remember this. If it's increasing, a function is increasing. When you're looking at the graph from left to right, the y value will increase as the x increases. So the one that I just drew, from this point on up, is increasing. You're always looking at it from left to right. It's decreasing if, again, as you're looking at it from left to right, it's going down. So here's my decreasing. Let's see if I can write that well. And then obviously the last one's going to be the constant. I need to pick a different color here. So that would be your constant if it is just going horizontal across. Okay? So I know that you learned that in Algebra 1, so it's not too unfamiliar to you. Okay. And you're always we're gonna describe it in terms of intervals, like interval notations. So you're always going to use open intervals, parentheses, for increasing, decreasing, and constant. We're going to do one below, so you'll see what I mean. Okay. A relative max versus a relative min. And then positive, negative. So let me draw one. Okay, this graph right here is going to describe all of these. Okay, relative max is a point where a function changes from increasing to decreasing. So again, looking at the graph from left to right, I'm going up the hill and then back down. There's my relative max. Okay, if I am obviously going down the hill to up the hill, looking left to right, going down the hill to up the hill, there's my relative min. Okay, so that one's pretty straightforward. The positive negative is something that not everybody remembers and that we still have a little difficulty with in Algebra 2. So listen up to this, okay? A positive is a function is positive if the function is above the x-axis, okay? So basically, I'm going to do it. Let me do it in yellow so you can see. If it's positive, it's anything. So this is my x-axis, by the way. You're not seeing my picture clearly. This is my x and this is my y, right? So I am positive if I am above the x-axis. So this part is above the x-axis. This part of the graph is above. And then obviously I'm negative if I'm below the x-axis. Here's where I'm below. Okay? And you're just going to list those using interval notation. You're going to tell me from what x values it's going to be a positive and what x values it's going to be negative. Okay? And it says, remember it says, note, 0 is neither positive or negative. So at that point where the function crosses the x-axis, an open interval should be used because at 0, it's not a positive or a negative value. Okay, so let's look at our example 1. go through this. Okay, using interval notation to determine the following about the graph to the right. So we're going to look at this graph to the right here, and we have to see where it is increasing. So I'm seeing this purple section right here is increasing, right? So that means when I read it from the left to the right. There is an arrow going left forever, correct? So that means that we are, from negative infinity, we are always, like if you're looking from negative infinity to the right, you're always going up a hill, okay? And it stops going up the hill, and I'm looking at the x's. It stops going up the hill at -2. See it right there? So from negative infinity to -2, it is increasing. So that is my increasing portion of the function. Where is it decreasing? Okay, so I'm going to say right here. And this is from 3 to all, like, just keeps going, right? It just keeps going down. So from 3 to, oh, you know what? I just realized that is not an arrow, is it? It's my poor sight, kiddos. This is a dot. So we gotta stop it. It doesn't go for infinity. So let's try that again. We go from 3, it stops at 8. See that? It stops at 8. So from 3 to 8, from left to right, from when x is 3 to when x is 8, right? We have going down the hill. When you're looking again from left to right, you're always looking left to right. So I'm going to remember, wrap these in parentheses. Remember what I wrote up here. It says open intervals, parentheses for increasing, decreasing count. Just basically, you're always using parentheses for increasing, decreasing constants. Always. You don't use anything but parentheses. Like, that's just a given. Always parentheses. Okay, and the part where it's constant means it's always horizontal. So it's horizontal at the purple here. And that is going to be from that -2, right, to that 3. So from when x is -2 to when x is 3 is where it's constant. All right. So let's talk about positive and negative first. So I'm going to erase all the color in here. You have recorded it. You recorded if you need to go back and look at it. Positive, remember, is where it's above the x-axis, right? Where it's above. So I'm going to say, okay, from here, I'm going to use my orange for Halloween. Here is my parts where it's above the x-axis. And I'm looking again, I'm looking at the x's. That's where I'm talking. I don't care about what the y values are. I'm looking at the x's, remember. So I'm going to say, okay, from when x is -6 to when x is 5 is where it is above the x-axis. Okay, we're going to use a pumpkin color, so we're going to use orange and green. Now I'm going to record here. I'm going to list here where is sugar roasted peanuts. I keep thinking that is an arrow. It's too small for me. There we go. Okay, the green is where it is below the x-axis. Okay, now remember there's an arrow here, which means that's like negative infinity. It's going forever, right? It's going forever and ever and ever to the left. So I'm going to say negative infinity, and it's going to stop being negative at -6, right? Because at -6 is where it hits the x-axis. Okay, so do you see that all right? All right. And then we're going to put a union here. Okay, the union here is the other part of the section where it is a negative. So the union means there's two pieces. Okay, so there was this part. Then we got to come over here to this. Now, remember, it started being negative when x was 5. And then it went to when x was 8. And those are going to be, again, wrapped in parentheses. Okay. All right, so there's two green sections, and that U just means union, means I'm going to take both these sections, and they're both going to represent negative. All right. I'm going to erase. We're going to talk about domain and range again, because I know this is still a little bit of a trouble spot for some. Okay, domain is your x's, right? So does it go left forever? So yes, as there's an arrow. See the arrow? As it is going left, it is going down. So I'm going to say it's going to continue to go to the left forever. Okay? Because as it's going down, it's moving to the left. So that's negative infinity. And then it stops here at 8. Right? There's no more graph after x is 8. After x is 8, it's done. And it includes a point at 8. So we're going to use that bracket. That's where the brackets come in here today. Okay, for the range, those are the y's. So what's the lowest it's going to go? Well, remember here, this keeps going down and down and down. So it's going to continue to go down forever. So I'm going to say negative infinity. And then this is the only time, by the way, that I look at y's. Every other part of this discussion, I've only looked at x's. Range is the only time I look at y's. And I'm going to come up here, and I stop here. And that is where your y is 3. And there we go. And it's a bracket, remember, at 3 because it includes a point at 3. Okay, so does this graph have any relative extrema? And we need to explain it. No, believe it or not, you do not count. You guys are going to think sometimes these are relative extremas, like these part right here. That is not. It is not a point of maximum or minimum. Remember that relative extrema, and I'm kind of breezing over it really fast, is this relative max and relative min. And it says it has to change from increasing to decreasing. So there's either going to be a peak, like a peak here, or a valley. That's the only way you can have a relative max or relative min. So it's not for this one, no. It never changes from decreasing or increasing to decreasing or decreasing to increasing. It changes from, like here, it changes from increasing to constant or constant to decreasing, but it has to be increasing to decreasing or decreasing to increasing. It has to be a peak or a valley. Excuse me, peak or a valley. Okay, next part. This is the part that I told you guys yesterday was going to be brand new. So we're going to do this page, and then I'm going to let you do that back page, the third page of your notes you're going to do by yourself for a little quick review. Okay, so another key feature for functions is whether or not the function is either even, odd, or neither. All right. If it is an even function, I'm going to start with a graph. It's going to be symmetric over the y-axis. Symmetric means that I can fold it at the y. So see how I can fold this one at the y right here? and the left and the right will look exactly the same. If it's odd, it's symmetric over the origin. And that means if I flip it 180 degrees, or I turn the paper upside down, the picture will look exactly the same. So if I were to take this and I were to flip my paper 180 degrees, the picture would look exactly the same. Okay, how do you prove this algebraically? Because this is the part that I was discussing yesterday that you're going to have to know. But if it's an even function, when I put a negative in the function, a negative x in the function, it will be equivalent to its original. And it's an odd function if f of negative x is equal to negative f of x. Okay? All right. So let's look at first the graphical ones. Okay, determine if the following functions is even, odd, or neither. Explain. All right, so if I'm looking here and I see, here's my y-axis. The left and the right look exactly the same. It's even because it's symmetric over the y-axis. All right, what about B? Well, let's see. If I take the y and I go to do the symmetry, I definitely do not see symmetry over the y. So here's my y-axis. I don't see that if I were to fold it at the y, the left and the right match. There's no symmetry there. Definitely not. If I were to flip it 180 degrees, this picture would look like that. It would be up there then. And that doesn't look the same either. So we have, oh gosh, my writing here. Let's fix my writing. We have neither. We have neither even or odd. Okay, and C, obviously there's one left, you know that I'm going to pick it. We're going to say this is an odd because if I were to flip it 180 degrees, or if I were to basically look at it about the origin is 0, 0, right? If I were to look at it about the origin, you can see symmetry here, right? You can see that they are crossing the origin from this point to this point. If I were to connect, see it? It is all symmetric about the origin. So it's odd because it is symmetric over origin. And when we explain that B, because we really should explain B, because that is the direction, we're going to say, to get your full credit, you're going to say it's not symmetric over y-axis or origin. So that's how you're going to define it. Okay, last part. Determine algebraically whether the following functions are even, odd, or neither. Now you can, if they didn't ask you for algebraic, you can put these in your y equals and look at the graph. That would be fine. But you have to prove it, okay? So in order to prove, I always say test even first, okay? And you'll see why in a minute. Test even first. So remember what even test is. It's where we put negative x in the function. Okay, so we're going to do this first. We're going to do negative f of negative x and make all the x's negative x. Okay, so when I remember I told you yesterday, if it is an even exponent, then that pops out as a positive x. It's squared. So that is the result of f of negative x. And you can see that this is the same as the original, right? So in this case, f of x, the original f of x function, is equivalent to f of negative x. So we say it's even because of this. Right? And yes, you have to write this. You have to write this like whole piece here to prove that it's even. Okay, so you're going to do for the next one, you're going to test even first. Always test even. So I'm going to start with my f of negative x. I'm going to put that negative x in there. Like that. And remember, if it is an even exponent, then it would pop out to be a positive x value, but this is an odd, which means it's negative x times negative x times negative x. And a negative times a negative is a positive, times another negative. That pops out as a negative x cubed. And then this one is just a plain old negative x to the first power. So a negative x times a negative 11 is positive 11x. And you can clearly see that f of negative x does not equal the original. Remember, this is the original. Okay, so it's not even, right? It's definitely not even. So then we got to test for odd. Now remember, odd is this, negative f of x. So that means I'm going to stick a negative in front of the whole function, right? And I'm going to distribute it. Remember, we did this yesterday, and I kept saying it's really important for today. So when I distribute it, this is what I get. Okay? Now, remember, above, it's odd if f of negative x is equal to negative f of x, right? So take a look. Here is my f of negative x, and here is my negative f of x. And look at those, they match. So it is odd because of that. All right, so if those two match, then you know it's an odd function. All right, loves, let's do one more. One more together here. Okay, again, testing first for even. I see that. Okay, so I have to the fourth power. That means then clearly, because it's an even exponent, that it's going to come out as a positive. But this has an odd exponent, so that's going to come out as a negative. All right, so I'm testing for even, and I see that that does not match. No. So because it doesn't match the original function, it is not even. Then I'm going to do my test for my odd. I'm going to stick a negative through the whole darn thing. And I see that that does not match my f of negative x, does it? Okay, so this is negative f of x, right? And this is a no, too, because remember how we checked for an odd was we saw that these two matched, right? F of negative x and negative f of x, they matched. So these guys don't match either, do they? These don't match. The f of negative x doesn't match the original, and the f of negative x and the negative f of x do not match. So it is not even, it's not odd. It's neither. And it's because And you have to state this. F of x does not equal f of negative x. And f of negative x does not equal negative f of x. And that's your test. Even, odd, or neither. All right, kids. This is your last question, and it's going to be right here. You're going to do a little graph. Use your y equals, for example, 4, and explain why it's a function. Remember the vertical line test, which we talked about yesterday. Talk about increasing relative maxes and mins. Determine if it's even, odd, or neither. And you're going to do it algebraically. And then I'm asking if this is an odd function. And remember to use your graphing calculator, because you're not going to understand how to like pop in. You can't do this one algebraically yet. So you're going to use your graphing calc to test this one. Okay, I'm out. Have a good night, good afternoon, and I will see you guys on Monday. Peace.